very glad to be here among you. As Tara mentioned, I'm the CTO of Scrptr, which is an IoT company. We're IoT specialists. More specifically, we're implementing an IoT development and execution platform on the cloud. And on top of this, we're developing vertical applications for the IoT, meaning IoT Internet of Things solutions. So I need to mention that it was a hard time figuring out how to write a presentation that would be exhaustive yet short. So I have a thread, I have a presentation. I'll use it as a thread. Don't hesitate to interrupt me or ask any question you like. Before we continue, I'd like to know if you're familiar with the Internet of Things or you've heard of the Internet of Things, but just a bit more than just reading about it. How many of you are familiar with the Internet of Things? Okay, so fair. And just to know how many of you are from a software or technical background. Okay. So it's going to be a bit technical. I'll try not to be too technical, but yet it's technical. So Scrptr is, as I mentioned, an IoT platform, and we're dealing with the IoT. So aside from the buzzwords, because everybody's speaking about the Internet of Things now, but what's interesting to us is to figure out how we're going to implement solutions that will work and will solve real life problems. It's not just about leveraging a wave. Okay, it's cool, it's the IoT, let's ride the wave, see how much money we can make out of it. It doesn't work like this. You have to solve real life problems. So we have some challenges that we need to resolve, and these challenges have an impact on the architectures we're going to put in place to support the Internet of Things. And this is where it starts becoming technical. So don't hesitate, again, if you're not from a technical background, please interrupt me and ask questions. So, sorry. Actually, oh, whoa, it doesn't render the colors at all. So I'm going to talk about today's challenges, which are the one we're currently dealing with at Scrptr, and other companies as well are dealing with these challenges. And I'll try to move forward to the very near future. When I say very near future, it's from a time scale from now till 3 years, maximum 5 years span. We cannot predict what's going to happen in more than 5 years. Even it's not predicting, it's just analysis and trying to figure out what direction to take. So I'll start with the current problems regarding data management, orchestration, integration, and interoperability. If I want to summarize a typical Internet of Things solution or application, well, you'll have on one end data providers, such as sensors, for example, a thermometer, a pressure sensor, a blood sensor, a heart sensor, whatever you want, a light sensors. And these sensors will be pushing data to some kind of storage. Now, we'll have to store the data, and this is a problem because, as you can imagine, we have millions of devices pushing millions and billions of data packages. So we start here with the first challenge, which is how are we going to store these data? What kind of infrastructure have we to put in place to be able to absorb the data? This is what we call big data, as you might have heard of. Next step is dig into the data, try to identify patterns, try to transform raw data into actionable data, into information. So I'd like to know more about my customers. I'd like to know more about the way my business processes are working. I'd like to know more about some patterns in a building, for example. For example, I'd like to decrease my energy consumption because I want to save some money and spend it into something else where I could invest. So I need to identify the patterns of how the energy is consumed in my building. Who's entering what room, when do we have meetings, when are we leaving the lights on, when are we turning the AC when there's no one in a room. So these are the kinds of patterns we'd like to identify through an analysis and decision-making phase. Of course, there's a lot of hype around the big data, but big data and decisions alone are not enough. So the next step is to start triggering actions, taking actions based on whatever data and whatever decisions you might have come up with. So this is the next step. We're going to execute actions. Usually, we're going to execute coordinated actions, such as executing business processes. And these processes are actually orchestrations of different services. They might have to interact with other devices, such as mobile devices, or more physical devices, such as smart locks, for example, or even talk to other cloud platforms. And here we have another challenge, which is the integration and interoperability challenge. The problem is with the IoT is that we don't have any standards. Actually, we have so many standards, we have so many existing standards and many new standards that no one agrees on a specific set of standards that we could leverage. We don't even agree on the way data should be exchanged or services should be exposed. So we have a real problem of how do we integrate with third-party services, third-party APIs, third-party clouds, third-party devices. And this is the interoperability problem. So these are sorry, to end of day, today challenges. And at Scrptr, we're dealing with all of these. We're providing a solution for every single problem. One of the core solutions that we provide is how to handle interoperability and integration with third parties. So moving forward, typically, current architecture for IoT services are cloud-based. So data management, data analytics, orchestrations, and even integration are handled at the cloud level on IoT platforms that will provide one or many of these services. This is what we provide as an IoT platform. And as a consequence, we can't trust technology. As a consequence, this is another challenge, by the way. As a consequence, all the business logic that we have is currently centralized on such platforms. So this has good sides and bad sides. Is this still working?
Yes.
OK. So for example, I mentioned that we have good sides. That's fine. But let's focus on the challenging sides. Well, centralized architectures and cloud-based architecture don't allow you to handle many possible scenarios. So for example, if you're dealing with a smart city scenario, and there's a lot to say about smart city, so it's a different conference. In a smart city scenario, you might need to manage traffic in a smarter way. And you might need to try to avoid accidents. You might need to avoid accidents by detecting whenever a pedestrian is crossing a street without paying attention to the light, and informing a car that is arriving at a very fast speed that a pedestrian is crossing. So this is the job of a traffic control system. Now, if this traffic control system is cloud-based, then you'll have to deal with detecting the pedestrian, sending the information to the traffic cloud-based system, which will process the event, detect that a collision might happen, then send an instruction to another red light to turn to red, and to the car to slow down. And all of this has to be done in less than 10 milliseconds. And this is impossible with a cloud-based infrastructure. You can't do this in less than 10 milliseconds. You can do this in maybe 50 milliseconds, but it's too much. You'll have an accident. Am I clear? So please, if I'm not clear, please don't hesitate to interrupt me. If you'd like me to continue in Arabic, I'm fine. Or in French. Another typical scenario is the smart home scenario. In a smart home scenario, you don't have to react very fast to any kind of event. The problem with the smart home scenario is that, for example, you have some devices distributed across the rooms, and your devices are continuously sending useless information. You're sending temperature is 22 degrees, temperature is 22 degrees, and what you're doing actually doesn't add any value, just bloating the network. And that's the problem. You're bloating the network because your application is on the cloud. So decision-making happens here. And decision-making will only happen if, for example, temperature goes above 25 or below 18 degrees. So it's just an illustration example. Please don't tell me that thermostat will be able to detect that temperature was above 25 degrees. I know. It's just an example, an illustration of centralized cloud-based architectures. Another illustration scenario is in the case of an oil pipeline. Now, if you have an incident that takes place at some point in the pipeline and oil pressure starts decreasing, you might want to take some actions. The problem is that if decision-making is on the cloud and you don't have an internet connection or any network connection at that point, at that moment, because you don't have usually internet connections in the desert, you have to wait for a satellite, for example, to pass by, then you have a problem. How are you going to be able to take a decision in that specific scenario? So no connection, no decision, because decision is centralized on the cloud. ما انتبهت أي ساعة بلشت. Okay. Any questions so far? Okay. So today we have to face some limitations of our own architectures. We have to deal with data transfer latency. Can't wait for data to go up and down. Round trip costs a lot. We have to deal with network congestion. We're just distributing and pushing data to the cloud, but we're not always in need of this data. We might have some processing bottlenecks because everything is falling back on the cloud infrastructure. So the cloud infrastructure, even if it can't scale indefinitely. You know, there are physical limits to scaling. Unfortunately, don't believe Amazon when they tell you they can scale as much as you want. Or it will cost you a lot, so much that it won't make any economic sense to keep on going. So you have to deal with processing bottlenecks, and you have to deal with centralized decision-making, which doesn't give you much autonomy to take local decisions when local decision is needed, as in this case. I have to take a local decision. I can't wait for a network to come up, send my data, and wait for some instructions. This brings me to actually a new model we're working on, an evolution of current architecture, which is about collaboration. So former models were, sorry, I'm going to get back a bit. Sorry. Oh. Former models, current models actually, are geared towards orchestration. Orchestration means you have a central decision-making spot, and it's coordinating, it's orchestrating multiple other nodes, whatever these nodes are. They can be applications, services, devices, whatever you want. So this is a centralized orchestration. And as you can see, it's not always an adequate model. So to get a bit into more details, in typical Internet of Things architecture, actually your devices are communicating with your Internet of Things cloud platform through other devices that are called gateways. So for non-technical users, gateways will allow you to move from one local network to a more global network. Okay? Fine? And you might have some protocol switch along the way. So why is this important? It's not because I'm giving you a course in networking or anything else. It's just to tell you that actually many of these networking devices, they're just like computers. They have some processing capabilities. They have processing power, you know. They're nice, even nice computers. So the question is, why not use their capability to offload the cloud infrastructure? You know, instead of pushing everything to the cloud, let's just leverage the processing capabilities that we have on the devices, on the devices here, on the gateways, and use their processing capability to take decisions, store data. So move part of this to the gateway. And this is what we call edge computing. We're moving part of the decision-making, data storage, processing to the edge of a network. Cisco has called this fog computing, FOG. Please don't misunderstand me. Yeah, FOG computing, fog, as opposed to cloud. So anyway, so instead of bloating the cloud infrastructure and the network to this cloud infrastructure, we're just delegating some local decision-making, pre-processing of data, transformations, you name it, to the local gateways, and referring to the cloud infrastructure when more advanced processing is required. So we're also working on this. Oh, wow. We're also working on this at Scrptr. We already have an edge-ready version of our own platform. So you can run Scrptr on the cloud, or you can run it at the edge of a network. Fine? So, second observation is that, as you might have observed as well.
Take your time.
Yeah, OK, I'm fine. Second observation is that performance and capabilities in general of hardware is increasing, whereas their cost is decreasing, the famous Moore's law. OK, so I thought I had more technical people around, so sorry for the others. You have a prototyping board called Raspberry Pi. Yeah, I know, you can't read it. Just to tell you that within 4 years, this prototyping board has seen its capacity increased by 4 times. So in just 4 years, and it's less expensive now than it used to be in 4 years ago. So if we take this into consideration, it makes sense to believe that, well, many of these devices will actually be capable of processing or dealing with part of the business logic that is already on the cloud or on the gateway even. So this is already what we have for web application and mobile application. So we're just reiterating whatever we had. And by the way, information technology is just reinventing already what we had, but adding just some topping on top of that, adding a few features and reiterating. It's always the same problems with the same solutions, but expanding a little bit. I can tell you I've been in this business for the past 17 years, so I know what I'm saying. So anyways, the point is that we're going to move to a cloud and fog edge architecture to a collaborative architecture where actually these devices here will collaborate with each other and not only do some processing, then refer back to the cloud. And you also will have collaboration taking place across cloud platforms themselves. So we're going to move, yeah.
Is there going to be interoperability between them?
That's the problem, but we're moving. Yeah, so we're working on interoperability. So as soon as you have interoperability guaranteed, you might believe that you'll stick to this interoperability, but we'll always have interoperability concerns, and most probably. Okay. So هلا نحن لانه سيليكون فالي ما عم تعمل شغلها اصلا مش سيليكون فالي بتقرر يعني انه there are so many players. I had a slide, I removed it. Today you have consortiums. You have around 15 consortiums working on standardization just for low-level protocols, for networking protocols, not mentioning higher-level protocols and how applications are going to talk with each other. For example, do you know Fitbit, the tracking device? So there are many competitors to Fitbit. They all provide the same service. Fitbit, WeThink, Jawbones, you name it, Nike, Adidas. They all provide the same, exact same service with the exact same data, but in different formats and with different services. I mean, software services. So that's a nightmare. And you can't have a standard for every single application. So at some point, you'll have to do the job yourself, and this is what we're doing at Scrptr. We're providing you with a standardized interface to talk to Jawbones, WeThink, Fitbit, you name it, the same way. And this is going to be the case for a long time. I don't think we're going to achieve some kind of agreement for everything. OK, now we enabled interoperability. We integrated with different APIs and services. This is the current situation. We're thinking a bit ahead of time how to enable collaboration to offload the cloud infrastructure and the network. And we have working prototypes, and we have edge environments ready. Now let's think a bit more ahead. So it's not for tomorrow. Tomorrow, يعني بكرة بعد بكرة. It's a bit far, within 2 years. But you have big companies already working on this, and we're working with them on this. First is decision-making with the amount of data can be done by humans, even if you leverage the current infrastructure, big data, blah, blah, analytics, whatever you want, you can't handle it yourself. Today, big data infrastructure don't take decisions alone. They need people to take decisions with what they have pre-processed for them. But this is not enough, because you will be overwhelmed by data and even patterns and whatever you want, and we won't be able to handle it. So we need multimodal interfaces. I don't only need a user interface, a graphical user interface. You know, I want to drive my car and talk to my mobile phone to trigger some kind of service. You've heard of Alexa, I guess, the Amazon Alexa. You know, okay, so this is a different kind of interface. It understands vocal instructions. We have increasing complexity. So increasing complexity means that we won't be able to define a business process from scratch and once. You know, a business process will construct itself as we learn from the execution of the business process. And when you can't define a business process, then you move from orchestration to more collaboration. You'll have to trust other entities to know what to do whenever they have to face a given situation. For example, you're a specialist of some kind of domain. I don't know anything in this domain. I'll have to leverage your knowledge to do whatever I need. And this is what's going to happen. So, and in order to have collaboration, you need autonomy. And autonomy means you don't have to rely on anyone else but yourself. So this is my, as you can see, it's a very elaborated slide. Basically, we'll need to inject artificial intelligence into our collaboration agents, turning them into collaborative agents. So collaboration agents means, yeah, we give you the tools to collaborate, but we don't handle collaboration ourselves. We don't understand anything. And collaborative means, we know what to do, let us do it, and you'll do your part. So we'll have to inject some machine learning for decision making, pattern recognition, handling multimodal interfaces, et cetera, et cetera. And I'm done. Okay.